All right, continuing here. 2.6. Excuse me, this can be loud. And I'm on number 11. All right, we have tangent of x over y equals x plus y. All right, so what I realize is on the left side, when I take the derivative, I'm going to have chain rule. I'm going to do derivative of tangent of something. And then when I get inside, I'm going to have to do quotient rule. And I'm going to recognize that part of the quotient rule has x, part of it's going to have y, so I'm going to have to use chain rule in there. So let me work through it and see what happens. The derivative of tangent of something is secant squared of that something, then times the derivative of what's inside. So I'm going to do quotient rule. It's the derivative of the top times the bottom minus the derivative of the bottom. I just changed notation on you. Let me go back to the Leibniz notation. The derivative of the top times the bottom minus the derivative with respect to x of the bottom times the top all over the bottom squared. That'll finish off the derivative of the left side. Derivative of the right side, since there's two terms, I'm just going to do derivative of each one separately. Like that. And now over here we have secant squared of x over y times, now the derivative of x with respect to x is just 1 times y, which is y, minus the derivative of y with respect to x, this is our dy dx. And then times x still to finish off the quotient there, all over y squared. And this equals the derivative of x with respect to x is 1, and then derivative of y with respect to x is dy dx. Let me see what this text is. I'll get to that later. All right, so here we need to isolate this, but there's another one in there. Remember, this secant is being multiplied through here. So I think what I'll do is distribute. Well, let me rewrite this part first. We've got secant squared of x over y times, now I can split this into two terms. It's y over y squared. That's the same as 1 over y minus, and then this over this, which is going to be x over y squared and then dy dx. Like that. So I just split it into two terms, and then equals 1 plus dy dx. And now I'll distribute this to here and here. So I'm just going to put that out in front, 1 over y, secant squared x over y, minus, now all this in front of that, x over y squared dy dx times secant squared of x over y, and then equals 1 plus dy dx. Now I had to do that so that I could release this from this parentheses. So there it is. This whole factor is, I'm going to move this whole factor to this side. I'm going to move the 1 to that side. So somebody is texting me repeatedly over and over and over. Let's see, I don't know if y'all can hear that, but dy dx is still on the right side, and then I brought this whole thing over, so now it's positive. X over y squared dy dx secant squared of x over y, like that. All right, both of these terms have dy dx, so I'm going to factor dy dx out. That was the goal. I'm going to be left with the 1 here. Then I'm going to have x over y squared secant squared of x over y. And then on the left side, I still have this, 1 over y secant squared x over y minus 1. All right, now just divide this thing through on both sides, and we're there. So the left side will be 1 over y secant squared x over y minus 1 over this thing over here, which is 1 plus x over y squared, not x squared over y. X over y squared secant squared x over y. And then that equals dy dx. And the book may try and clear fractions here. They may multiply by y squared on the top and bottom. That way this will turn into a y, and then you'll get a minus y squared there. This will turn to a y squared, and when you distribute the y squareds cancel. So you just got the x part there. But this is correct. We have solved for dy dx. All right, let me just check this to make sure there's nothing majorly important here. Blanca, who's Blanca? All right, 12. Square root of x plus y equals 1 plus x squared y squared. All right, on the left side, we have root of something, which means we have chain rule. We have to take the derivative of the square root of something, which is 1 over 2 roots of that something, times now the derivative of what's inside. And since it's two terms, I'm going to take the derivative of x with respect to x, which is 1, plus the derivative of y with respect to x, which is dy dx. Very important, though, that I have this multiplication in parentheses, because this must distribute through to both. Equals derivative of a constant is 0, and then here we have a product right there. So I'm trying to work a little faster now. I'm going to do derivative of this times this plus derivative of this times this. Derivative of x squared is 2x times the second function plus the derivative of y squared with respect to x is 2y, so that's the power rule, 2 comes down. Then the derivative of y is tacked on, dy dx, then times the first function x squared. So that's your derivative. I need to free this, so I need to distribute. Here to here is itself, plus here to here, I'm just going to put the dy dx on top of the 2 over root x plus y. And then equals over here 2xy squared plus 2x squared y dy dx. I just slid this out here. And now I have this factor, or that term right there, and that term both have dy dx in them, so I'm going to get them to one side. So how about we move that over to the left side? So I'll have this piece here still. I'm going to move this piece over, so it's going to become minus 2x squared y dy dx equals, now this piece over here needs to come to the right side, and this piece was still there, so 2xy squared, but I'm minusing 1 over 2 root x plus y. Both of these have dy dx in them, right? Right here, so I factor that out. I'm left with 1 over 2 root x plus y minus 2x squared y equals 2xy squared minus 1 over 2 root x plus y. And then I divide this over here on this side. Let me just do that real quick. Shortcut, 1 over 2 root x plus y minus 2x squared y. And when I divide that out, all I'm left with is dy dx. So dy dx is this. And again, the book may go a little further. They may multiply the top and bottom here by 2 root x plus y, 2 root x plus y, like that, because when you distribute there, you get something ugly, but here it cancels. Here it cancels, and then here it's ugly. But they might do that, they may not. 13, I think I'm going to leave you to do 13. I think you can handle it. It's an odd number, so you can check your answer in the back of the book. $17. All right, for 17, they say if f of x plus x squared and then f of x cubed equals 10 and f of 1 equals 2, find f prime of 1. All right, well, we need to find the derivative of this function at 1. They tell us that the function's value at 1 is 2. So it's kind of like we know that at 1, the function's value is 2. We don't really know what it's doing, but we want to find the slope of the tangent line there. So we need to know what the derivative of the function is. We actually need to figure out what f prime is. So from this, here's what I'm going to do. I'm going to take the derivative, right? I've got f of x. I can take the derivative straight away. The derivative of f of x is f prime of x plus, now this is a product rule right here. That's multiplication between these two things. So I'm going to use the product rule there. Derivative of the first one, derivative of x squared is 2x times the second one, which is f of x cubed plus the derivative of this thing. So we have, you know, my tau, whatever, cubed. The derivative of my tau cubed is 3 times f of x squared. Chain rule says now take the derivative of what's down here. Derivative of f of x is f prime of x. And then times the first function, which is x squared. So I'm finishing off product rule. That must equal, that must equal 0, because the derivative of this side is constant, the derivative constant is 0. So this is it right here. I would now like to know what f prime of 1 is. So I'm wanting to know what's happening at the x value of 1. So I'm going to come in here and I'm going to replace all my x's with 1. So f prime of 1 should, plus, 2 times x, but that's 1, times the function's value at 1 cubed plus 3 times the function's value at 1 squared times f prime of 1 times 1 squared is 1 should be equal to 0. Now we know in the problem they tell us what f of 1 is. We know what those two values are, right? F of 1 is 2. So I can rewrite this now as f prime of 1 plus 2 times 1, which is 2, times, this is 2, 2 cubed is 8, plus 3 times, now f of 1 is 2, 2 squared is 4, so 3 times 4, and then times f prime of 1 times 1 is f prime of 1, so f prime of 1 must equal 0. So let me clean that up a little bit. this is going to be f prime of 1 plus 16 plus, now just multiply 3 times 4 there, 12 times f prime of 1 must equal 0. And we're almost there. Look at, I have 12 f primes of 1, and I have one of them. And if I add those two together, that gives me 13 f prime of 1s plus 16 must equal 0. And if I move that 16 to the other side, 13 f prime of 1 equals negative 16, and then divide both sides by 13. F prime of 1 equals 16 over 13. All right, this was number 17. I'm just going to double check in the back. That just seems like a weird answer. Yeah. Oh, sorry, I forgot the negative. Negative, because it was negative 16. All right, number 20. Use implicit differentiation to find the equation of the tangent line. So finally, we're going to find the equation of the tangent line of this curve. X squared plus 2xy minus y squared plus x equals 2. And we're going to do this at the point 1, 2. And I want to know the equation of the line at that point. So we already know to find the equation of the tangent line, we use this. We already know y1 is 2. We know x1 is 1. We just want to know what the slope of this line is. And to do that, we need to actually find the derivative at 1. Right? Find the derivative at 1. So in other words, we need to find dy dx at 1. At x is 1. So we need to find the derivative first. So let's find the derivative. Now I'm going to work very quickly through this. I have, let's see, 1, 2, 3, 4 terms on the left side. I do have a product rule right there. It's this 2x times y. So first, starting with this, derivative of x squared is 2x plus product rule. Derivative of 2x is just 2 times the second function plus derivative of the second function is dy dx times the first function, 2x. Move on, minus derivative of y squared is 2y, but then because of chain rule, times dy dx. And then plus the derivative of x, well, since we're differentiating with respect to x, it's 1. And that must equal the derivative of the right side, which is 0. So what I could do now is I could try and solve for dy dx. But because I actually am looking at a specific point, if I replace my x's with 1s, my y's with 2, I should have a nice equation. My x's with 1 and my y's with 2, then I should have a nice equation for the derivative at that point. So this is going to become 2 times 1 plus 2 times 2 plus dy dx times 2 times x, which is 1, minus 2 times y, which is 2, dy dx plus 1 must equal 0. If I can solve this for dy dx, I have my answer. So we have 2 plus 4 plus 2 dy dx, that's this, minus this, which is 4 dy dx, plus 1 must equal 0. So let me put my dy dx's together. Those together gives me negative 2 dy dx. And so I've got those. And then now my numbers, 2 plus 4 is 6, plus 1 is 7. So I have plus 7 equals 0. Move the 7 to the other side. Negative 2 dy dx equals negative 7. Divide both sides by negative 2. You get 7 halves. So that means that the slope of the tangent line at this point 1, 2 should be 7 halves. So this should be y minus 2 equals 7 halves times x minus 1. That should be it. Now for number 22, same thing. I know I'm working faster through these, but I'm hoping you've done enough practice with the implicit differentiation right before this and the previous problems that I can work at this speed. X to the 2/3 plus y to the 2/3 equals 4. And the point that we want to look at is negative 3 root 3, 1. Negative 3 root 3, 1. And they even give you the graph of this. We call this an asteroid, like this. That's the graph of that. And so we're going like, this is a terrible graph. We're going like to negative 3 root 3, goes up to 1. We're trying to find the slope of the tangent line there. So I already know that the equation of the tangent line is y minus 1 equals m times x minus x1, which would be plus 3 root 3. So that's my equation. I just need to know the slope of the tangent line there. So I need the derivative. So let me take the derivative over here implicitly. All right, this has just x in it, so it's going to be 2/3 x to the negative 1/3 plus, now same thing, take derivative of this, just use power rule, 2/3 y to the negative 1/3, but because this is y and y is a function of x, we say chain rule times the derivative of y, which is dy dx, and then equals the derivative of 4, which is 0. And I actually know what my x is and my y is, right? So let me come in here. I'm going to clean this up a little bit because it's going to be kind of tough to look at. I have 2 over 3 x to the negative 1/3. I drop it down. That's the cube root of x plus this one right here, 2 over 3 cube root of y, and then dy dx equals 0. So I'm going to replace my y with 1 and my x with negative 3 root 3. This is going to be ugly. Really ugly. So this becomes 2 over 3 times the cube root of x, which is negative 3 root 3, and then plus 2 over 3, and then the cube root of the y, which is 1, and then times dy dx equals 0. This is nice because the cube root of 1 is just 1, so this just becomes 2/3. That one not so nice. But what I'll do is I'll move this to the other side first. So when I move that to the other side, it'll become 2/3 dy dx equals, that to the other side is negative 2 over 3 cube roots of negative 3 root 3. And then I'm gonna get the dy dx by itself. I'm gonna multiply by 3/2 and multiply by 3/2 like that, so that this right here will just become a 1, and we get dy dx is equal to, and then over here the 3 cancels with this 3 and the 2 and the 2, so I have negative 1 over cube root of negative 3 root 3. And I really don't know if I should mess with this anymore. Let's try and mess with it. I don't like that as a slope. So let me try and convince you of something. This negative 3 root 3, that is the same as negative square root of 9 root 3, because 3 is actually the square root of 9, right? I know that looks weird that I do that, but now I can put those back together. This is negative root 27, right? Which is the same as negative 27 to the half, right? That's what that is. But see, I'm supposed to be taking the cube root of all that. So what happens if I take the cube root of all this, the cube root of all this, the cube root of all this, and the cube root of all this? Well, what I could do I could rewrite this as negative 27, right? Now 27 is to the 1/2, right? The negative is not raised to the 1/2, it's just to the 27. And then I'm doing all of that to the 1/3. And so many different ways you could look at this. If I multiply those two exponents, I get 1/6. So negative 27 to the 1/6, that would be an answer. Another thing you could do is you could rewrite this as negative 27 to the 1/3 to the 1/2, like switch the order. It doesn't matter which order you do those in. And this means cube root of 27. The cube root of 27 is 3. So this is negative 3 to the 1/2, and that's just negative square root of 3. I like that. I like that a lot. Let's go with that one. So we have here that this turns into negative 1 over this whole thing, which we said was negative root 3, which is just 1 over root 3. And if you rationalize, multiply top and bottom by root 3, you get root 3 over 3. And it seems like there would have been an easier way to get to that. I might be working too hard. That's our slope, though, and that goes right here. Root 3 over 3. All right, number 25. Find the second derivative. All right, so this is going to get a little bit weird, all right? I'm going to use a different notation here. Please understand that when I'm doing this, number 25, please understand when I'm doing this, that y prime equals dy dx. All right, that's the assumption. That's what I mean by y prime. It means the derivative of y with respect to x. And I'm going to do 9x squared plus y squared equals 9. 9x squared plus y squared equals 9. And I would like to find y double prime. All right, so let me take the derivative implicitly. Derivative of this with respect to x is going to be 18x. That's straightforward. Here, the derivative of this, the 2 would come down because y depends on x. It's 2y, but then times dy dx. But I'm going to write y prime instead. And just understand that means the dy dx equals derivative of 9, which is 0. Now at this point, I can solve for y prime, or I could just take the derivative again. And I think that's the way I'm going to do it. I'm just taking derivative again. So what is the derivative of this right here with respect to x? That would be 18 plus, now I'm taking derivative of this. I have a product rule, so be real careful here. What is the derivative of 2 times y? Well, 2 is going to come along for the ride. And then the derivative of y is y prime times the second one, y prime again, plus now the derivative of the second one. The derivative of the derivative is the second derivative, then times the first function, 2y, then equals the derivative on the right side of 0 is still 0. So please understand, this right here is the product rule on this. 18 plus, now y prime times y prime is not y double prime, that's y prime squared. So I'm going to write y prime squared, and then plus 2y double prime equals 0. I'm trying to solve for y double prime. So I'll take this and this. Well, let me just move that to the other side. 18 plus 2y prime squared equals negative 2y y double prime. So just subtract it on both sides. I'm going to divide both sides by negative 2y now. I could do it like that if I wanted to. Or I could just do one long bar. Let me do one long bar and just do one down here, negative 2y. And so what we have is that y double prime equals this divided by this, the 2, this turns this into a 9, that turns that into a 1. So I should just have 9 plus y prime squared over, this right here was negative y down here, negative y. Now I'm sure that that's okay. I wonder if they go and do more simplification. They probably do. Let me do this. Let's solve for y prime on this one so we can plug it in up there. So if I solve for y prime, I get 2y y prime equals negative 18x. I'm moving the 18x to the other side. If I divide by 2y, so under here 2y, under here 2y, I get y prime equals 9x, negative 9x over y. And for the bottom here, I need a y. So I could solve this for y by moving this to the other side and then taking the square root. And you can get plus or minus 9 minus 9x, 9 minus 9x squared. So now let me try and rewrite this. This will be equal to, y double prime will be equal to 9 plus y prime, which is this, but squared. So square the top and bottom. You should get 81x squared over y squared over plus or minus the square root of 9 minus 9x squared. And that does not look like a pretty thing. Let me see. 25, 26. Whoa. What am I missing here? Y double prime. Mm, 18x, 9, 0. That's right. And then we had 18. The answer in the back is so much cleaner than this. Wondering, do they clean this up? Okay, let's do this. Let's do this. Let's not replace this y. Let's just leave this as negative y, like that. Okay, now let's get a common denominator on the top. This is going to be 9y squared plus 81x squared over y squared. That's a common denominator on top right there. Then all of this over negative y. And then notice on the top, if I factor out a 9, this will be 9, and then it'll be y squared plus 9x squared. So tricky. Over y squared, and then all of that over negative y. But what is 9x squared plus y squared? 9x squared plus y squared is actually 9. So this thing right here is just 9. So what we get is y double prime equals 9 times 9, 81, over y squared, over negative y, which I can write as a fraction. And then when you flip this like this, you get a final answer of y double prime equals negative 81 over y cubed. Interesting. I believe all of these problems work that way. So I believe I'm going to let you try 27 on your own and 29. However, hi, do you need this?
Can I?
Yeah.
Are you free to?
Yeah, no.
Just I can interrupt you, but I hate
Yeah, I told him anytime. I was just saying like they're going to finish the rest of this on their own. So
okay, no worries.
I'm good.
I had to be at 2.
2?
Mm-hmm.
Okay.
Still good.
Oh, so I have 5 minutes? It's 1:40.
No, like
So I'm okay for 5 minutes? Okay.
Yeah,
All right, good.
thank you, sorry.
All right, no, it's fine. Okay, I'm going to let you do 27 and 29 on your own. I'll do 26. Trying to find y double prime. Square root of x plus square root of y equals 1. And, all right, here we go. Derivative of root x, 1 over 2 root x. Plus derivative of root y is 1 over 2 root y. However, you have to take derivative of what's inside. And derivative of what that is y prime. So there's your chain rule, equals 0. All right, I do not like this, because I have to take derivative again. So let me rewrite this back with powers. let's do it that way. So I just brought these things up as rational exponents. Now when I take my derivative again, the negative 1/2 comes out. I get negative 1/4 x to the negative 3/2. And then when I do derivative here, I have a product rule. So I do derivative of the first one. Be real careful here. Derivative of the first one, the negative 1/2 drops out. That's going to be minus 1/4 y to the negative 3/2. But you have to take derivative of what's down here too, because it's chain rule. Derivative of that is y prime, and then times the second one, y prime again. Then finishing product rule plus the derivative of the second one, derivative of y prime is y double prime, and then times the first one, which was 1/2 y to the negative 1/2. And that must equal 0. What a disaster. What a disaster. So let me see if we can't clean this up. This looks really, really bad. Let's get the y double prime term by itself. So this is 1/2. I'm going to rewrite this right here. Actually, I'm going to write that as 1 over 2 root y. That's this piece right here. Times y double prime equals, now I'm going to move this to the other side. So 1 over 4 x root x. So what I did was I dropped this back down and I did the square root of x cubed, gives me this. Bring that one to the other side, plus 1 over 4 y root y, same story. But I have attached to that y prime squared. Wow. Okay. Let's try and get y double prime by itself. Let's multiply both sides by 2 root y. Top on the top here. 2 root y over 1. Same thing over here. So when I do it here, it goes away. I have y double prime equals. Now I'm multiplying this one by 2 root y and this one by 2 root y. And we will get, let's see, a root y over 2x root x. That's what that simplifies to be. Here, the root y's cancel. I get plus 1 over 2y y prime squared. And I'm really hoping I can like do something with this. Let's try this. What was y prime? Let's go back over here. Let's figure out what y prime was. I do 1 over 2 root y, y prime equals, move that to the other side, negative 1 over 2 root x, and then multiply the reciprocal on both sides. It goes away here. I'm multiplying a 2 root y here. 2's cancel. I'm getting y prime is equal to root y over root x, but negative. And if I put that in right here, right, and square it, I'm just going to get y over x. And the y's cancel. And so that leaves me with y double prime equals root y over 2x root x plus 1 over 2x. And so what I can see here, I can get a common denominator. I can put a root x up here and a root x down here. I know I'm working fast. They're kicking me out of this room. So now I have a common denominator. If I put these two together, I get root y plus root x over 2x root x. But I know that root x plus root y is 1. So I get 1 over 2x root x. Okay, I gotta go. That was cool.